Assalamualaikum friends, welcome to my channel Random Opinions. Today I have a topic for you guys, network topologies. So what is network topology?
Network topology refers to how various nodes, devices and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city and topology as the roadmap. Just as there are many ways to arrange and maintain a city, such as making sure the avenues and boulevards can facilitate passage between the parts of town getting the most traffic. There are several ways to arrange a network. Each has advantages and disadvantages, and depending on the needs of your company, certain arrangements can give you a greater degree of connectivity and security. There are two approaches to network topology, physical and logical. Physical network topology, as the name suggests, refers to the physical connections and interconnections between nodes in the network, the wires, cables, and so forth. Logical network topology is a little more abstract and strategic, referring to the conceptual understanding of how and why the network is arranged, the way it is, and how data moves through it. The question arises, why is network topology important? The layout of your network is important for several reasons. Above all, it plays an essential role in how well your network functions. Choosing the right topology for your company's operational model can increase performance while making it easier to locate faults, troubleshoot errors, and most effectively allocate resources across the network to ensure optimal network health. A streamlined and properly managed network topology can increase energy and data efficiency, which can in turn help to reduce operational and maintenance costs. The design and structure of a network are usually shown and manipulated in a software-created network topology diagram. These diagrams are essential for a few reasons, but especially for how they can provide visual representations of both physical and logical layouts, allowing administrators to see the connections between devices when troubleshooting. The way network is arranged can make or break network functionality, connectivity, and protection from downtime. The question of what is network topology can be answered with an explanation of two categories in the network topology. As I mentioned earlier, physical and logical. The physical network topology refers to the actual connections, wires, cables, etc. of how the network is arranged, setup, maintenance, and provisioning tasks require insight into the physical network. Number second is logical. The logical network topology is a higher level idea of how a network is set up, including which nodes connect to each other and in which ways, as well as how data is transmitted through the network. Logical network topology includes any virtual and cloud resources. Effective network management and monitoring require a strong grasp of both the physical and logical topology of a network to ensure your network is efficient and healthy. So another question arises, what is the most common type of network topology? Building a local area network topology can make or break for your business, as you want to set up a resilient, secure, and easy to maintain topology. There are several different types of network topology and all are suitable for different purposes, depending on overall network size and your objectives. As with most things, there's no right or one size fits all options. With this in mind, I will walk you through the most common network topology definitions to give you a feel for the advantages and disadvantages of each. So coming to the network topologies, number first is star topology. What is star topology? A star topology, the most common network topology, is laid out so every node in the network is directly connected to one central hub via coaxial, twisted pair, or fiber optic cable. Acting as a server, the central node manages data transmission as information sent from any node on the network has to pass through the central one to reach its destination and function as a repeater which helps prevent data loss. Advantages of star topology. Star topologies are common since they allow you to conveniently manage your entire network from a single location because each of the nodes is independently connected to the central hub. Should one go down, the rest of the network will continue functioning unaffected, making the star topology a stable and secure network layout. Additional devices can be added, removed, and modified without taking the entire network offline. On the physical side of things, the structure of the star topology uses relatively little cabling to fully connect to the network, which allows for both straightforward setup and management over time. as the network expands or contracts. The simplicity of the network designs makes life easier for the administrators too, because it's very identify where errors or performance issues are occurring. Disadvantages of star topology. On the flip side, if the central hub goes down, the rest of the network can't function. But if the central hub is properly managed and kept in good health, administrators shouldn't have too many issues. The overall bandwidth and performance of the network are also limited by the central node's configurations and technical specifications, making star topologies expensive to set up and operate. So, another topology is bus topology. A bus topology orients all the devices on a network along a single cable, running in a single direction from one end of a network to the other, which is why it's sometimes called a line topology or backbone topology. Data flow on the network also follows the route of the cable moving on the direction. So, coming to the advantages of bus topology. Bus topologies are good, cost-effective choice of a smaller networks because the layout is simple, allowing all devices to be connected via a single coaxial or RJ45 cable. If needed, more nodes can be easily added to the network by joining additional cables. So coming to the disadvantages of bus topology. However, because bus topologies uses a single cable to transmit data, they are somewhat vulnerable. If the cable experiences a failure, the whole network goes down, which can be time-consuming and expensive to restore, which can be a less of an issue with smaller networks. Bus topologies are best suited for small networks because there's only so much bandwidth, and every additional load will slow transmission speeds. Furthermore, data is half duplex, which means it can't send in two opposite directions at the same time. So this layout is not the ideal choice for a network with a huge amount of traffic. So the next topology is ring topology. What is ring topology? Single versus dual. Ring topology is where nodes are arranged in a circle or ring. The data can travel through the ring network in either one direction for both directions, with each device having exactly two neighbors. So advantages of ring topology. Since each device is only connected to the ones on either side, when data is transmitted, the packets also travels along the circle, moving through each of the intermediate nodes until they arrive at their destinations. If a large network is arranged in a ring topology, repeaters can be used to ensure packets arrive correctly without data loss. Only one station on the network is permitted to send data at a time, which greatly reduces the risk of the packet collisions, making ring topologies efficient at transmitting data without errors. By and large, ring topologies are cost-effective and inexpensive to install, and the intricate point-to-point connectivity of the nodes makes it relatively easy to identify issues and misconfigurations on the network. So what are the disadvantages of ring topology? Even though it's popular, a ring topology is still vulnerable to failure without proper network management, since the flow of data transmission moves unidirectional between nodes along each ring. If one node goes down, it can take the entire network with it. That's why it's imperative for each of the nodes to be maintained and kept in good health. Nevertheless, even if you are vigilant and attentive to node performance, your network can still be taken down and by a transmission line failure. The question of scalability should also be taken into consideration in ring topology. All the devices on the network share bandwidth, so the addition of more devices can be contribute to overall communication delays. Network administrators need to be mindful of the devices added to the topology to avoid overburdening the network's resources and capacity. Additionally, the entire network must be taken offline to reconfigure, add and remove our nodes. And while that's not the end of the world, scheduling downtime for the network can be inconvenient and costly. So the next topology is tree topology. The tree topology structure gets its name from how the central node functions as a sort of trunk for the network, with nodes extending outward in a branch-like fashion. However,
where each node is a star topology is directly connected to the central hub. A tree topology has a parent-child hierarchy to how the nodes are connected. Those connected to the central hub are connected linearly other nodes. So two connected nodes only share one mutual connection because the tree topology structure is both extremely flexible and scalable. It's often used for wide area networks to support for many spread out devices. So advantages of tree topology. Combining elements of star and bus topologies allows for the easy addition of nodes and network expansion. Troubleshooting errors on the network is also a straightforward process, as each of the branches can be individually assessed for performance issues. And disadvantages of tree topology. As with the star topology, the entire network depends on the health of the root node is an inner tree topology structure. Should the central hub fail, the various node branches will become disconnected through connectivity but no between branch systems will remain. Because of the hierarchical complexity and the linear structure of the network layout, adding more nodes to a tree topology can quickly make proper management and unwittingly not to motion costly experienced tree topologies are expensive because of their sheer amount of cabling required to connect each device to the next within the hierarchical layout. So another topology is mesh topology. A mesh topology is an intricate and elaborate structure of point-to-point connections where the nodes are interconnected. Mesh networks can be full or partial mesh. Partial mesh topologies are most interconnected with a few nodes with only two or more connections, while full mesh topologies are surprise, fully interconnected. The web-like structure of a mesh topology offers two different methods of data transmissions, routing and flooding. When data is routed, the nodes use logic to determine the shortest distance from the source to destination, and when data is flooded, the information is sent to all nodes with the network without the needs for routing logic. Coming to the advantages of mesh topology. Mesh topologies are reliable and stable, and complex degree of interconnectivity between nodes makes the network resistant to failure. For instance, no single device going down can bring the network offline. And the disadvantages of mesh topology. Mesh topologies are incredibly labor intensive. Each interconnection between nodes requires a cable and configurations once deployed, so it can also be time consuming to set up. As with other topology structures, the cost of cabling adds up fast, and so to say mesh networks requires a lot of cabling is an understatement. So moving forward, another topology is hybrid topology. Hybrid topologies combine two or more different topology structures. The tree topology is a good example, integrating the bus and star layouts. Hybrid structures are most commonly found in larger companies where individual departments have personalized network topologies adapted to suit their needs and network usage. Coming to the advantages of hybrid topology. Advantages of hybrid topology. The main advantage of hybrid topology structures is the degree of flexibility they provide, as there are few limitations on the network structure itself that a hybrid setup can't accommodate. Coming to the disadvantages of hybrid topology. The disadvantages of hybrid topology, however, each type of a network topology comes with its own disadvantages, and as a network grows in complexity, so too does the experience and know-how required on the part of admins to keep everything functioning optimally. There is also the monetary cost to consider when creating a hybrid topology. So the question is, which topology is best for your network? No network topology is perfect or inherently better than others, so determining the right structure for your business will depend on the needs and size of your network. Here are some key elements to consider. Length of the cable needed, cable type, cost, scalability. Cable length. Generally, the more cable involved in a network topology, the more it will require to set up. The bus and star topologies are on the simpler side of the things, both being fairly lightweight, while mesh networks are much more cable and labor intensive. And cable type. The second point to consider is the type of cable you will install. Coaxial and twisted pair cables both use insulated copper or copper-based wiring, while fiber optic cables are made from thin and pliable plastic or glass tubes. Twisted pair cables are cost-effective but have less bandwidth than coaxial cables. Fiber optic cables are high-performing, can transmit data from faster than twisted pairs and coaxial cables, but they also tend to be far more expensive to install because they require additional components like optical receivers. So as with your choice of your network topology, the wiring you select depends on the needs of your network, including which applications you will be running, the transmission distance, and desired performance. Another is cost. As I have mentioned, the installation cost is important to account for, as the more complex network topologies will require more time and funding to set up. This can be compounded if you are combining different elements, such as connecting a more complex network structure via more expensive cables through using fiber optic cables in a meshed network is overdoing it. If you ask me, because of how interconnected the topology is, determining the right topology for your needs then is a matter of striking the right balance between installation and operating costs and the level of performance you require from the network. And number last is scalability. The last element is considered is scalability. If you anticipate your company and network spending, or if you'd like to be able to, it will save your time and hassle down the line to use an easily modifiable network topology. Star topologies are so common because they allow you to add, remove, and alter nodes with minimal disruption to the rest of the network. Ring networks, on the other hand, have to be taken entirely offline for any changes to be made to any of the nodes. So coming to the network topologies in 2020, the best advice I can give you regarding network topology is that you should be deep familiar with the needs and usage requirements of your network. The total number of nodes on the network is one of the primary considerations to account for, as this will dictate whether it's feasible to use a simpler topology or whether you will have to make the investment in a more complicated network structure. As I mentioned earlier, no one topology is best. Each offers its own set of perks and drawbacks, depending on the network environment you are working with or attempting to set up. For this reason, I would avoid jumping to immediate conclusions about any of the network topologies based on solely the descriptions here before deciding. Try using a network topology mapping tool to sketch the layout you are thinking about it. So I hope you get my point. Thank you all.